Hello there, I trust you're well. So in this demo, I'll be taking you through how to calculate the Sharpe ratio through this platform that I created. And basically, this is the formula for calculating the Sharpe ratio. So a portfolio return minus risk-free rate over the standard deviation of the portfolio. So that's the formula. Maybe this on a side note, a lot of these things will be hidden behind buttons, so you definitely won't be needing to do a lot of these calculations. But I understand there are some people who would like to create new variables and optimize their portfolios using those variables. So that's actually why I'm currently developing this platform where they can create the new variables and use those variables to optimize their portfolio. So okay, to continue, this is the formula, and one of the things you'll need to do is to create your portfolio. So you can do that as simple as following. You can just add those two assets, and let's say my portfolio, I want it to consist between Apple and Alphabet, Google here. So when I add them, you can see here that they have a lot of detail. The fundamental place has been populated with a lot of details regarding them. If you want to understand these assets better, you can check maybe bit size, ask size, shares, short ratio, blah blah blah, a lot of details. We want to go into details. We won't go into that much. So so this is the formula. I'll take you stepwise. So first step, let's find what's the risk-free rate. This one you can Google. I'll just guess. Say it's 1%, and that's the yearly risk-free rate. I'll just say it's 1%, and let's work with that. So that's done. When I do that, this one's a valid mathematical expression, and when I do that, you can see here it's given me, it's added it among the variables. It's added risk-free rate among the variables that I can use throughout the rest of the process. These ones are not valid, and that's why they have been ignored. So so that's the risk-free rate. This part here is done. What about the portfolio return? Portfolio return, I'll start with Apple equals, I'll take the average return of Apple in the last 365 days. So Apple return, daily return, 365 days. I want 365 days what return, and I want them daily, so it will give me 365 values and daily, and it will average that. So this one's average daily return in the last 365 days. I'll do the same thing with Google. I'll do the same thing with Google, and I'll say 365 days, 1 day, like that. And now I have both Apple and Google. Give it a second, and now we have this both of these values here. So that those are average daily returns in the last 365 days. Of course, I'll want to annualize them, and I'll probably, this is not the best approach, but I'll just use it. I'll just multiply by 365, 365, like that. And now I have the returns, the average annual return the last year, and Google the same thing. So what next? So I'll assume this is the return I'm going to get. What next? I'll say weights. I'll have to create the weights for my portfolio. So I'll say I want 0.7% to go to Apple and 0.3 to go to Google. So 70% of my money I'll give Apple and 50% on Google while buying the shares. So we have the weights, and my portfolio return, basically it's the weighted average return of these two. So it is basically I'll matrix multiply weights times transpose Apple return and Google return, like that. And portfolio return, give it a second. Boom, we have the portfolio return at 0.075, so less 5%, 5.7%. So that's portfolio return. We are done on that. So the next up thing is about the standard deviation of our portfolio. portfolio standard deviation. So the first thing I'll do is I'll get the returns minus the average. So I'll say Apple minus average, Apple return minus average. So basically it's the return 365 days minus the average return minus the average return, the return minus the average return, like that. And I'll do this one because this average returns a single value you saw here, and you can't minus a matrix by a single value. So this MAVG, it's a matrix form. It will return a matrix, but that matrix will have the same value everywhere. It will basically be the same shape as this one, but the value will be the average return. So I'll do that, Apple minus average, and I'll do the same with Google. Equals Google minus average. I'll just copy this one and I'll replace this ones with Google. Okay, so now I have the average minus return. So the next thing is calculating the portfolio standard deviation, the portfolio covariance matrix. So covariance matrix, the covariance matrix, and it's taking time to return my Google results. Apple minus average, Google minus average, Google return 365. Okay, it's back. Okay. Okay, so the covariance matrix is basically a matrix, calculator matrix. So my return matrix equals Apple minus average and Google minus average, Apple minus average and Google minus average. Apple minus average and Google minus average. So a covariance matrix will be multiply this one by itself, multiply that one by itself. So R transpose return matrix by itself, return matrix like that, return matrix by itself. So Google minus itself. This one return matrix, you can see it's 365 by 2 shape. This one 365 by 1, 365 by 1, and the covariance matrix is 2 by 2. So that's our covariance matrix. There's something I'm forgetting. Okay, I'll have to divide this value by the number of the sample size. I'll have to multiply this one by the sample size. So this one basically divide by count. The sample size basically it's 365. It's 365. Let's just say 365. 365 divided by 365. Okay, so okay, so after doing that we can proceed. Once we have the covariance matrix, we know that we can just get the variance, and I'll do this in a series of steps. Matrix multiply variance, matrix multiply the weights by the covariance matrix, like that. That's step 1. Step 2, I'll matrix multiply x, whatever I'll get here in x times the weights again, like that. Matrix multiply x by x again. So x it's 0.00 blah blah blah. Okay, and why is that? Actually this one is our results. You multiply weights, it's like weights um, times covariance matrix times now the transpose version of it. This is the formula. Maybe I should write it here so that you can see what's going on. So covariance matrix equals weights times uh, times this one, covariance matrix. The variance equals weights times the covariance matrix, and then again the results here we again multiply by the weight again, like that. So that's the formula, and this multiple is matrix multiplying here, this by these stars here, the matrix multiply. So at this point we have the variance. Why is actually our variance? Why it's actually our variance? And to get our standard deviation we have to just find the square root of that, like that. So we have the variance of our portfolio like that. We have the standard deviation, actually portfolio standard deviation equals that. We have our portfolio standard deviation. So we've completed everything. We've calculated the risk-free rate, the portfolio return, and we've calculated the portfolio standard deviation. So what's the Sharpe ratio? Sharpe ratio is just the portfolio return. I'll just copy this one here, portfolio return minus risk-free rate. I'll just copy it here over the standard deviation of the portfolio, like that. And let's see what we get. And we get 2.8.4.7. That's a very very big value. It's like it say that's an excellent portfolio. Anyway, so that's it for now. Catch you on a later one, and I'll definitely be developing this one more, and I'll be making this one more take less time, maybe, for instance, to calculate this stuff. So thanks for listening. Till we meet next time.